Guys, welcome to US Education Hub. So today we are going to start with a new chapter, which is matter in our surroundings. So this is the chapter from class 9 CBSE, and this is your master teacher SUVOPRIYO, and let's start the chapter. So, before starting the chapter, if you have ever downloaded a Telegram app from Play Store or iOS, then please join our Telegram channel. All kinds of PDFs, workbooks, tests, etc. will be given in this channel, and then the link of this channel is being given in the description box below. So join the channel right now. So we know that our country today is facing a big struggle due to COVID-19. The spreading of COVID-19 in our country is simply very big, and for which our country is facing a tough situation for the timing. So we need to follow all the preventive acts that is being given by you as well as our country's medical associations. So we should wash our hands timely, and we should cover our cough or sneeze, or we should not touch anywhere like our personal sense organs like eyes, nose or mouth while we are in a road or somewhere when we are facing, and then we should keep our distance while we are facing a crowd. We should keep away from ourselves from the crowding place, and we should try to stay at home. We should not move at house because this is a fight we need to fight with each and every people in our country. So we need to team up with each and everyone among our surroundings, and then only we will be able to win this war. And we should get help from different kinds of helpline numbers that are we being given by our country medical associations and our government as well. So we should take care of COVID-19. And before that, let's start the chapter. So, what is matter? So, starting the chapter with a question: what is matter? So, matter is something that is present in each and every particle. The it may be what means matter we can see in our everyday surroundings. So, we read the definition now. Matter is anything which occupies space and has mass is called matter. It is anything which occupies space and has mass. So, if a substance is occupying a space and has mass, we can call it as matter, because if a substance is not looking like a matter but a substance is being made up of matter. So, air and water, sugar and sand, hydrogen and oxygen, etc. We have examples of matter like air and water, sugar and sand, and hydrogen and oxygen. So, matter is made up of very small tiny particles. So, atom is the most small tiniest particle, but before atom we have quark. Quark is the tiniest particle in this whole world. Quark. So after quark, it is atom, and then atom, a number of atom forms into a matter. So matter is also a very tiny particles. Matter can be gaseous, matter can be solid, matter can be liquid as well. So particles of the matter have space between them, they attract each other. So particles of matter, small tiny particles of matter, have space between them, and they used to attract each other. So I think it's the matter topic is very much clear to you. So let's move to the next slide. So we have the five basic elements that are water, we have air, we have sky, and we have earth, and we have fire. So earlier, different kinds of scientists, philosophers used to tell that on the basis of matter is the thing which is being made by these five basic elements, and based on this, matter is a substance. So these are the elements, and matter is a particle. So let's move to the next slide. So physical nature of matter. So physical nature can be of a matter can be divided into three uh, parts that we have described before as well. So one of them is solid, the other one is liquid, the third is gas. So based on these three, matter exists, but nowadays these apart from these three, there are different kinds of other physical nature of matter exists. So beforehand we discussed about these three categories only. So one of them is solid. Solids are molecules are tightly packed. The molecules which are present inside a solid, in a solid substance, it is the molecules are very much tightly packed. They are very much hard and rigid. And then we have liquid. Molecules are loosely packed and as compared to that of solid, and they take the shape of the container. For example, if we pour water in a glass or a vessel, we can see that it is taking the shape of the vessel. So this is means this is how it takes the shape of the vessel or the glass, and then we can see how the molecules are being present in solid as well as the molecules how they are present in the liquid as well. So let's move to the third one, gas. Molecules of gases are farther apart when compared to liquid molecules. So in this figure, we can see the solid molecules. So these molecules are very much tightly packed to each other. They are very much rigid. They are having the fixed shape and fixed volume. In this case, they are loosely packed compared to solids, and they are not rigid, have some fixed shape, but when it is poured inside a vessel, it has fixed shape and then fixed volume they have. But in this case, yes, they do not have a fixed shape, they are not rigid, and they do not have any fixed volume. The gaseous atmosphere, which is around us, doesn't have any kind of fixed shape. They doesn't have any kind of rigidity. So, and they also doesn't have any kind of volume. Hope this physical nature of the matter, which is based on solid, liquid, and gas, is simply crystal clear to you. So let's move to the next slide. So, solids. So we are going to discuss the three categories in very much in depth and in detail. So in fact, first, the solid particles are tightly packed and closely packed. So in this image only, we can see that these solids are simply tightly packed and they are closely packed, and then the gaps between the particles are then are tiny, and hence it is tough to compress them. We cannot compress the solid particles. It's simply impossible as they are too much tightly packed and they are closely packed, and for which it is simply tough to compress them. Solids has a fixed shape and fixed volume. They have a fixed shape. As they are tightly and closely packed, they are giving a fixed shape and rigidity, and they are having a fixed volume. And then due to its rigid nature, particles in solid can only vibrate about their mean position and cannot move. So as they are unable to, means their particles are so tightly and closely packed for which they cannot move, and for which they cannot vibrate, and they cannot change their positions and cannot move as well. So force of attraction between the particles is adamant. So the force of attraction between the particles are simply, they are very much adamant, and then the rate of diffusion in solids is very low. Diffusion, I think it's very much clear. The diffusion is simply a process that is being continued in biology, but diffusion in this case is similar to as well as biology as well. So diffusion is solids is very much low. An example is solid ice, sugar, rock, wood, etc. So these are some of the examples of solids. So oh, solids are very much clear to you. So let's move to the next slide. So liquids. Liquids, in this figure only we can see that the molecules of the liquids are not tightly packed. They are taking the shape of the vessel in which they are being kept, and they can move easily as the particles are not tightly or closely packed. So let's see what the definition tells. So liquid state of matter is an intermediate phase between the solid and gas. Like the particles of the solid, particles in the liquid are subject to intramolecular attraction. However, liquid particles have more space between them, so they are not fixed in position. Attraction between the particles in the liquid keeps the volume of the liquid constant. The liquid state of matter is an intermediate phase between solid and gas. So neither the molecules of the liquid are tightly and closely packed, and neither the molecules of the liquid are simply like the molecules of the gas, because the molecules in the gas are simply moving as the molecules are wanting. So not like that the molecules of the liquids, so they are simply intermediate. And like the particles of solid, particles of the liquid are subject to intermolecular attraction. So, like solids, the liquid molecules of the liquid are having a little intermolecular attraction between them, between each and every molecule of the liquid. However, liquid particles have more. Sorry, that slide was changed. So the however the liquid particles have more space between them, and so they are not fixed in position. So the liquid particles have more space between them. So we can see from this figure only. And so they are not fixed in position. So they are not fixed in position like the solids, because the intermolecular there is having a lot of space between each and one and another molecule, and that's why they are not having fixed position. The attraction between the particles in the liquid keeps the volume of the liquid constant. So in this figure only we can see there is an attraction between one and another molecule. So there is a attraction, and that's why there is the volume of the liquids. The volume of the liquid is simply constant. So the movement of the particles causes the liquid to be variable in shape. The movement of particles causes a liquid to variable in shape. So the these molecules are being present in this vessel, and they are simply made as per they are kept in a particular vessel. For example, this vessel is in a rectangular shape. So the liquid, it may be water, it may be milk, it may be oil, it may be anything which is in nature with the liquid. So they are taking simply the shape of the vessel. So liquids will flow and fill the lowest portion of the container, and taking on the shape of the container but not changing in volume. That doesn't change in volume. The shape of the container may be so thin. In that case also they will not change in volume. The vessel would be so thick, and in that case also they are not changing their volume. The limited amount of space between the particles means that the liquid have only very limited compressibility. So we cannot compress the liquid. We cannot compress the solids as well as we cannot compress a liquid, but there is certain limitation in the compressibility. But after that, in neither nor cases, in exceptional cases we can also compress liquid as well, but in normal cases we cannot compress liquid because the molecules are having attraction with each other, and the shape they having is taken as per they are being placed in a vessel and they are having a fixed volume. So hope you have understood what is liquids and the structure of the liquids and the intermolecular species as well as the attractions between one and another molecule. So let's move to the next slide. So gases. So gases is a matter state of matter that has no fixed shape and no fixed volume. So these molecules doesn't have any fixed shape and fixed volume. Even they are being kept in a vessel, we cannot keep gas in a vessel. But then if we store gas, like we used to store oxygen in this crisis period, which we are facing presently, a huge amount of oxygen cylinders are being transported from oxygen plant to the hospitals. So in that case, the oxygen which is present in the cylinder, they are having no fixed shape because in the cylinder the oxygen molecules are simply moving from one end of the cylinder to other end, so they are not having any fixed shape and they are also not having any kind of fixed volume. Now gases have lower density than other states of matter. So till now we have discussed two states of matter, one is solids and one is liquids. So compared to solids and liquids, the density of gas is simply very much low, and there is a great deal of empty space between the particles which have a lot of kinetic energy. Now, the empty space between one molecule and another molecule is very huge, and that's why they are having a lot of kinetic energy between these molecules present in the gas. The particles move very fast and collide into one another. As they are simply very much independent, and that's why these molecules used to move very much faster and even sometimes used to collide with each other. With each other, they used to collide and then causing them to diffuse or spread out until they are evenly distributed throughout the volume of the container. So they are being diffused or spread out and then until they are evenly distributed throughout the volume of the container. So within seconds only, the molecules of the gas used to fill up the total container or the total volume of the container within seconds, because they used to move faster. Each and every molecule of the gas used to move faster and cover up the total space they are being given with or they are being presented with. So this is the basic structure of the gas. The basic structure we can see when the water falling from clouds, when like that, and this is a basic structure of the gas. So hope you're able to understand what is gases, the state of matter, and let's move to the next slide. So can matter change its state? So when we ask this question, we always say yes to this question. Yes, because matter can at any moment they can change its state on the basis of their environment. For example, liquid is a basic one. So liquid in everyday life we used to drink water. So drinking water, while we if it is a hot summer day, we used to keep this water in bottle and then we freeze it or we keep in a refrigerator. If for any situation we forget to bring out the bottle from the refrigerator, and then it becomes the water present in the bottle then freezes and forms ice. So this freezing makes the water to be solid. Then again, if we melt this ice, then we will get liquid. Now, too much heating of ice can cause water vapors, which is as gas. So water vapors is the too much heating, so it will rise up as gases, as water vapor. Now we can restore this water vapor by cooling it, and then it will form liquid again. Then it will again, if we freeze it, then will again it will form ice. So this is a continuous cycle that is being described in this image, and let's read what it does. So matter changes when energy is added or taken away. So this is a kind of energy in each and every state. So either we take the energy, then it will form the if we take the energy, or we will give the energy. So taking out the energy, it will form solids. Giving the energy, more energy, it will form gas. So matter changes because of heat energy. So in this case, liquid, if it is being heated, then it will form gas. If it is being cooled or it is being given with cold energy, then it will form solid, means freezing. Now changes in pressure can change matter too. Changes in pressure also causes changing of matter as well. So next is the atoms and molecules that make up the matter are always moving. They are always moving. Atoms and molecules inside a matter. Even the molecules in solids are moving, just not very much. In solids, movement of molecules is not very much. We have described about solids, and we have seen the image of solids beforehand, and that's why they are not very much moving. But they move, but it is very slowly, and that's why we can say that it is not much moving. When matter is heated enough, the molecules move faster with greater energy. When matter is heated, by for example, we have seen that in solids, in solid ice, when we heat it, it will form liquid. In this case, the solid ice, the molecules in the solid ice will move faster, for which with greater energy, and for which it will turn to liquid. If enough heat is added, a solid can become liquid and a liquid can become gas. So we have discussed beforehand itself that this may occur, but even if we give too much heat to the solid and it will form straightly to gas, then it can be called as latent heat, because the total amount of heat a particular substance can take, and over it, if the heat is being provided to a particular substance, then it can move to a straightly to this gas, a gaseous form. And then if enough heat is can become gas, in the same way the molecules slow down when they are cooled. So if they are slow down, that will form liquid, and if it is more slowly down, then it will form solid. Matter that is cooled to a certain point changes. For example, a liquid becomes a solid. So we have discussed that if we freeze the gaseous, the water vapor, then it will form liquid. When we um, freeze the liquid state or the water state, then it will form the ice, which is as solid. So hope you have understood that can matter changes heat. So I think you have got the answer, and let's move to the next slide. So effects of change of temperature of matter. So on the basis of temperature, different kinds of effects occurs, and for which the state of the matter also sometimes changes. So on increasing the temperature of the solids, the kinetic energy of the particles increases. If we increase the temperature of solids, then the kinetic energy of the particles which is present inside the solid is becomes increases. Now due to increase in the kinetic energy, the particles start vibrating with a greater speed, because we have discussed previously that if we heat solid, then the particles of the molecules and the atoms which are present inside the solid state, and they will move at a high speed, which is in kinetic energy, and there will be increase in kinetic energy, and thus the energy supplied by the heat overcomes the forces of attraction between the particles. the energy supplied by the heat overcomes the forces of attraction. This means that the energy supplied by the heat, so the energy which is being supplied occurs the forces of attraction between the particles which is present in the state. If the solid is being heated, then the state of attraction increases. If the force of states overcomes the force of states of attraction, if the liquid is being heated, then force of state of attraction. So like this, the particles leave their fixed positions and start moving more freely. So we have seen that the more we heat, the attraction decreases, and for which if the attraction decreases, then only the state of the substance will change. If the attraction increases, that means we are freezing a particular state, and for which the state, if it is gas, if we giving freezing condition, then it will, the force of attraction between the molecules will increasing, and if we freeze a liquid, the force of attraction will increase between the molecules of the liquid, and then it will form solid. So simply it's vice versa. If we heat, the molecules of the state will be having force of attraction will be decreasing. If we freeze, the force of attraction between the molecules will be increasing. So like this, the particles leave their fixed positions and start moving more freely. So we have discussed now itself. A stage is reached when the solid melts and is converted to liquid. So the heat which our solid needs to melt to a liquid. So this temperature makes for the conversion of the solid to liquid, and then the temperature at which the solid melts to become a liquid at atmospheric pressure is called its melting point. So melting point, we call it as a melting point. Now when liquid is changed to gas, then we'll have boiling point. So the temperature at which the solid simply changes or converts to a liquid, that means the temperature of the solid has been crossed, and for which the solid has been converted to liquid. Now, the temperature of the liquid, if it is being converted, means the temperature at which the heat should be moving, if it has crossed, then the liquid will also convert it to the gas. And when liquid is converted to gas, it is known as a boiling point. When solid is being converted to liquid, the point is known as the melting point. So, hope you have understood the effects of change of the temperature of matter. So, let's move to the next slide. So, effects of change of pressure in matter. So, by applying pressure, we can bring the particles of the matter closer and closer. So, by applying pressure, we can bring the particles of the matter closer and closer. In the temperature, we have seen that overcome of the particles occurs with a particle of matter occurs, and for which attraction becomes, means the attraction decreases among the molecules. And now we have seen that due to the effects of the change of pressure, the matter is coming closer and closer. So by applying the pressure, solids can be converted into liquids, and further applying more pressure, liquids can be converted to gases. So here in this case as well, by applying pressure, we can convert solid. In the temperature topic, we have seen that while we are giving more temperature, we can convert solid to liquid and to gas. And then in this pressure as well, we can convert solid to liquid to gas. So in this image you can see, and this further applying more pressure can be converted into gases. So hope you have understood the effects of the change of pressure. Now let's move to evaporation. So what is evaporation? Now evaporation, when the temperature of increases, then due to high temperature, the water bodies like ocean and sea, bays, gulfs, lakes. So these are the water bodies. So in these water bodies, the evaporation of water occurs. For example, you can do an experiment like if we take a vessel and which we fill up with the water, small vessel, if we fill up with the water and keep in the place where it high sunlight is being coming, and for a period of time, for a period of long time, we can say, then after some time we will see that the water is being displaced, means the water is not present in that place. From that condition we can see that evaporation is occurring. So evaporation occurs in this way. Now let's read what evaporation does. The process by which an element or compound transitions from its liquid state to its gaseous state below the temperature at which it boils, in particular the process in which liquid water enters the atmosphere as water vapor. So this the process of by which an element or a compound transitions from its liquid state to gaseous state below the temperature at which it boils. So below the temperature which it was, the evaporation occurs, in particular the process by which the liquid enters the atmosphere as water vapor. Now the atmosphere, the the liquid water is being entering into the atmosphere as water vapor, because without water vapor, the liquid cannot enter into the atmosphere as evaporation. So water vapor isn't needed for the liquid water to move into the atmosphere. Evaporation mostly from the sea and from vegetation replenishes the humidity of the air. Evaporation mostly occurs from the sea and also from vegetation. The vegetation means green plants. The green plants like transpiration. What is transpiration? Transpiration occurs, this is a biological term. Transpiration occurs when too much of water is being released from the stomata. Now stomata, the water released from the stomata then goes up into the air, and in that case also evaporation occurs. Now replenishes the humidity of the air, and this evaporation occurs the humidity in the air. Now, for example, the places which are near to the water bodies, like the places which are near to Bay of Bengal, now the places which are near to Arabian Sea. So those places, the percentage of humidity has always been higher than the places which are landlocked, means the places which are away from the sea. So in those places, the percentage of the humidity always is lower, but in place where it is closer to the sea, they used to have high humidity. So it is an important part of the exchange of energy in the earth atmosphere system, and that produces atmospheric motion, therefore weather and climate. So evaporation is an important factor, as it plays a vital role in the exchange of energy in the earth atmosphere system, and that produces the atmospheric motion and therefore weather and climate. And this evaporation plays an important role in the weather as well as in the climate. I think you know what is weather, and I also think you know about this climate. This is the terms used in geography as well. So the rate of evaporation depends on the temperature difference between the evaporating surface and the air, the relative humidity and the wind. The rate of evaporation depends on the temperature. Now the rate of evaporation means the amount or the at what the rate of the evaporation depends on temperature difference between the evaporating surface and the air, the relative humidity and the wind. Now all these criteria makes the rate of evaporation increases. If the rate of evaporation increases, means all these criteria like temperature, difference between the evaporating surface and the air, the relative humidity, the wind, these, if it increases, the rate of evaporation also increases. If they decreases, then the rate of evaporation also decreases. So these are the factors. So hope you have understood what is evaporation. So I think evaporation is very much important as for the exam point of view. So you should be able to understand the concept of evaporation should be crystal clear. So let's move to the next slide. So factors affecting the evaporation. So a number of factors are affecting the evaporation. Let's look one by one. So temperature of the liquid, a cup of hot water will evaporate more quickly than a cup of cold water. So the hot water will evaporate more quickly because the hot air which is present over the hot water is lighter, and that's why it will move up. and while this air moves up, it will carry the water, and this air which carries water, it causes evaporation, and that's why it moves up. While the cup of cold water, because the cold water and the temperature over it is cold, and that's why cold air is very much lighter, means it is very much heavier, sorry, it is very much heavier, and that's why it will lie at the bottom, and that's why it will not move up in the atmosphere very much faster. That's why hot water does this. Next, we have exposed surface area of the liquid. The same amount of water will evaporate more quickly in a wide shallow bowl than in a tall narrow glass. So exposed surface area of the liquid means an exposed surface area, for example, the water bodies, large water bodies, the same amount of water will evaporate more quickly in a wide shallow bowl than in a tall narrow glass. Hence, there will be no difference, but then in a wide shallow bowl, the evaporation will be much faster or much quicker than a tall narrow glass. Tall narrow glass means a tall vessel with having a narrow width, and in that vessel the water will not evaporate quicker than the wide shallow bowl. So next point, presence or absence of other substances in liquid, pure water will evaporate more quickly than salt water, because there is a because while we take salt water, not only salts as well as different other kinds of compounds or some kinds of particles which are not seen by our naked eyes. These kind of particles are present in salt water. Now, salt water means the sea water or the ocean water. So these water contains various kinds of numerous kinds of particles, and that's why it is very much slower. I will not say that it will not evaporate, but the amount of evaporation is slower. But in case of pure water that we drink regularly, so pure water doesn't contains any kind of, but the uh, components in the pure water, I will say, doesn't contains anything, but it is containing something, but then the particles are not in numerous quantities, so the pure water will just evaporate much quicker than salt water. So let's move to the next point. Air movement clothes on a clothes line will dry more quickly on a windy day than on a still day. So if we hang our clothes, means wet clothes, in a um, windy day, the evaporation occurs much faster. And if we hang our clothes in a normal day, means only sun's energy or the solar energy is coming up, there is no amount of heat, or means no amount of wind is blowing, or the speed of the wind is lower, on that day the cloths may take some time to get drier than the day like the windy day, because windy day makes the cloths more drier and helps to make the cloths more dry, but then on a still day doesn't occur, this facility doesn't begin, doesn't. So concentration of the evaporating substance in a air and then clothes will dry more quickly when air contains little water vapor. So when air contains little water vapor, little amount of water vapor, it helps the cloths to make drier quickly. But if the air doesn't contains any water vapor, so it becomes slower for the cloths to become dry. Now, how evaporation causes cooling? Now, evaporation also causes cooling as well. So, during hot summers, the water is usually kept in earthen pot to keep it cool. Water is cooled in the pot since the surface of the pot contains large pores of water and uh, or large pores and water. So, during hot summers, the water is usually kept in earthen pots. So in various places we have found that people doesn't have any kind of refrigerators. So people used to keep the water in the earthen pots. Means the when mud is being solidified, and on those pots, those are known as earthen pots, and in those pots the water is kept so that the temperature of the water is not hot, and that's why they should be cool, Because cool water we used to drink because getting energy from a cool water is much more better than getting energy from the hot water. So water is being cooled in this pots since the surface of the pot contains large pores of water, pores and water. So these pot, the surface area of this pot contains large pores of water because the temperature inside the pot is lower, but the temperature outside the pot is the temperature around. So the temperature is higher, and that's why the the vessel gets wetted, and that's why the water inside it becomes cooler. Now, since via these pores of outside of the pot, and these water evaporates and takes a latent heat for vaporization, hence wettening the water inside the pool. So we have discussed. Next, we have especially in villages, people often sprinkle water in the front of their homes during hot summers. In the hot summers, we cannot place our feet in the normal bare feet in the ground because the temperature of the ground also rises to a high temperature for which it is simply impossible for us to place our feet, bare feet in the ground. That's why people in the village, please, used to sprinkle buckets of water in front of their house, courtyard, and that's why from which they can place and the temperature of the ground becomes cooler. Now, water vaporization from leaves of trees also cools the surroundings. Water vaporization, the trees, where trees are there, the trees used to give away a lot of water, and for which a lot of water vaporization occurs, and for which it makes the surroundings to be cooler. Now, next point is the desert cooler cools better on a hot and dry day. So desert coolers are the coolers which are being used in a hot and dry weather, and they helps to make ourselves cool in this hot and dry day. It is a common observation that we are able to sip hot tea faster in the saucer from a saucer than from a cup. It is common observation. We have observed commonly that we can able to sip hot tea or hot milk faster from a saucer. So saucer is a kind of thing that we use while to make the tea or the milk to boil up, and that is much more easier and much more faster, basically much more faster than we drink it from the cup. Now, wearing cotton cloths in summer days to keep the body cool and comfortable. Now, cotton cloths helps. Now, what is the difference between cotton cloths and woolen cloths? If we go in depth in these topics, in this cotton cloth and woolen cloth, in that case, we can see the cotton cloth, the fabrics which are being used, the fibers and fabrics which are being used in this cotton cloth. These fibers and fabrics, they are having the species between the threads, between the fibers from one fiber to another. They have species in cotton cloths, and these species lets the air outside and the air inside the cloths and air outside the cloths helps to replace their places, for which we wear cotton cloths in summer days. But in case of winter season, it is simply impossible to wear cotton cloths because winter woolen cloths we wear because the woolen cloths, the fibers and fabrics we use in the woolen cloths, those threads doesn't those cloths doesn't have species between the threads because the species are not present in the threads, for which the air inside the cloths and the air outside the cloths doesn't get replaced, and for which we feel warmer and we feel relief from the cold chill weather, and that's why we wear cotton cloths in summer and winter clothes, means woolen cloths in winter. So I think you're able to understand how evaporation causes cooling as well. So there was the last point as well. Put a little spirit on your hand and wave around. The spirit evaporates rapidly and our hand feels cooler. So here spirit means alcohol. So alcohol, when we put a little alcohol, nowadays we are giving sanitizers to our hands, alcohol based sanitizers. So we can see that when we place alcohol based sanitizers in our hand, we feel after some period, after seconds, we can feel that our hand feels cooler rapidly. So this is also an example of evaporation. So another point as well, we sweat to cool. Now we sweat to cool means the more we sweat, the more cooler we feel. Now, oversweating is not good, but if we sweat normally, then we will sweat and we will feel cool from our inside ourselves, and that sweat will, as the sweat gets evaporated, and we feel cool. Refrigeration occurs on the same principle. So refrigeration also occurs on this same principle. So why should we wear cotton clothes? Now only we have discussed about this. So this is basically we sweat more in summer season. It is very much necessary that we will sweat in summer season. So cotton is a strong water absorber, helps to absorb the sweat and introduce to the environment of the evaporation. Our body takes out the heat as the sweat evaporates from our body, and therefore our body loses the heat as it is cooled. So this is the reason why we wear cotton cloths in summer, because they are best water absorbers or the strong water absorbers. The, as we sweat in summer, the water is needed to be absorbed, and that's why cotton cloths are the best in summer seasons. Now, why do we see water droplets on the outer surface of the glass containing ice cold water? Now we have discussed this previously as well with the earthen pot example. Like this, the temperature inside the glass is too much cool because ice is present inside the glass. But in the outside temperature is too much high, so that's why the glass gets sweated. And this is the reason. This phenomenon is known as a condensation. So this phenomenon is known as condensation. Cold water inside the water tries to cool down, and the water vapor in air which comes in contact with wall of glass, and due to low temperature the vapor liquid and appears as water droplets on outside of the glass. So this is the another example why we see water droplets, and this water droplets when occurs in our body, it also feels cool because when we sweat, this occurs, and after some time, when the sweat gets evaporated, we feel cool. This also occurs when people in villages used to sprinkle water in their grounds to make the ground cooler, and they can barefooted, they can walk over it. So these are all similar kind of examples till we have discussed. So hope you have understood this example as well. So let's move to the next slide. Plasma. So till now we have discussed only three categories of matter or three states of matter. One is solid, liquid, gas. Now we will talk about plasma. Now what is plasma? Now plasma is a state of matter where the gas phase is energized till until the atomic electrons are no longer associated with any particular atomic nucleus. Plasmas are made of positively charged ions and unbound electrons. Plasma may be produced by either heating a gas until it is ionized or by subjecting it to a strong electromagnetic field. Now, about plasma in depth, you will be able to be learning in it in the higher classes. But then, about the basic matter or the basic what is plasma, if we discuss in basic, then it is a simply uh, matter where the gas phase is energized. This gas phase is simply energized until the atomic electrons are no longer associated. The atomic electrons are no longer associated with any particular atomic nucleus. Now, nucleus is being present and they are not no longer be associated with a particular, with a single or a particular atomic nucleus. Now, plasmas are made of positively charged ions and unbound electrons. Now, positively charged ions means protons. Now, positively charged ions, these plasmas are simply made up of the positively charged ions or protons. and they are unbounded with electrons. Now plasma may be produced by either heating a gas. We can produce plasma by heating a gas, but this occurs only in the labs, and they are being produced by heating a gas until it is ionized. When it occurs ionization, when it occurs with a gas, then subjecting it to it a electromagnetic field, a strong electromagnetic field, and subjecting to a strong electromagnetic field. So hope you have understood plasma. We have not discussed plasma in class 9 because plasma is not in depth, and we need not to discuss the basic or the in depth of plasma, what is plasma, but then a basic we have discussed. Hope you are able to understand, and let's move to the next slide. The Bose-Einstein condensate. This is also a state of matter. Till now we have discussed solid, liquid, gas, plasma. This is another one. It is Bose-Einstein condensate. So it was of the five matters. Matter can be seen in Bose-Einstein condensate. Is perhaps the most mysterious gas, liquid, solids, and plasmas we are all well studied for decades, if not centuries. Bose-Einstein condensates weren't created in the laboratory until 1990s. Bose-Einstein condensate weren't created until 1990s. After 1990s was being created. And then a Bose-Einstein condensate is a group of atoms cooled to within a hair of absolute zero, and then when they reach at a temperature, the atoms are hardly moving relative to each other. They have almost no free energy to do so. At that point, the atoms begin to clump together and enter the same energy states. They become identical from a physical point of view, and the whole group starts behaving as though it were a single atom. So there is a group of atoms to within a hair of absolute 0 degree. When they reach that temperature, when the temperature is reached to 0 degree, then the atoms are hardly moving relative to each other. They moving, are moving relative to each other. They're related to other atoms, and then they have almost no free energy. It doesn't contain or consists of free energy to do, and then at that point of atoms begin to clump together. They used to clump together and enter the same energy states. Now also Bose-Einstein condensate is also being discussed in various science labs, and they are being discussed in the laboratories. Scientists are culturing about Bose-Einstein condensate, and we would be getting more results from Bose-Einstein condensates, and we would be knowing more about this state of matter. So till then, this is the end of this session. Thank you for watching this video, and hope all your concepts are simply crystal clear. We have discussed this chapter in each and every part and in detail. So hope all your concepts are simply crystal clear. And if you have any doubts, mention it in the comment section below, and simply we take a lot of efforts to make these conceptual videos, to make your concepts simply crystal clear. So for that, please hit the like button and subscribe the channel and press the bell icon to get regular updates, and share the video as much as you can. Try to share the video with those students or those future of our country who are willing to study, but due to some problem, due to circumstances, they are unable to. Then share these conceptual videos with them and let them to study. So till then, stay tuned, practice, and let's bye bye.